Okay, hi everyone. So now part 2 of the weather chapter. The second video is looking at weather instruments. So I'm going to teach you how they measure temperature, wind speed, sunshine, etc. So like I said before, you can watch this video back as many times as you need. You can pause it and it will really be a good revision tool as well, okay? Right, so the first one anyway we're going to look at is measuring the temperature, because we all like to know like what degrees is it out there today. Is it 17 degrees? Is it going to be 30 degrees? Is it going to be -4? So temperature is important to know that, because it affects, you know, what clothes we'll wear and what activities we can do. So temperature is the degree of hotness or coldness of the atmosphere. So the temperature outside tells us how hot or how cold it is. You all know that. How do we measure temperature? With a thermometer. We do the same when we're sick. You know, you've had that when you're small. If you have a fever, your parents probably measured your temperature with the thermometer at home. We do the same for the weather. So how we measure the temperature outside is in degrees Celsius, okay? So like I said, 17 degrees Celsius, 30 degrees Celsius, etc. Now on a weather map that the meteorologists prepare, and you can see one there on the right hand side of your screen, those lines on the weather map tell us what the temperature is like. So they're called isotherms, okay? So isotherms. So that might be helpful if you were ever watching a weather forecast in the summertime and you see the forecast presenter talking about the temperature and how hot it's going to be. They will show a map of Ireland and they'll show you the lines on the map and how hot it's going to be. Obviously the redder area there, you can see the lines are quite close together and the temperature might be getting hotter, etc. Okay? So what do we have now? How do we measure the temperature using a thermometer? Now, it's called a minimum and a maximum thermometer. If I just scroll on there, I'll show you a picture of one. There's one. Have I another one? No. Okay, so that's a minimum and a maximum thermometer. Now, just going back to this picture back here. How does it work? It's a U-shaped thermometer, different looking now to the one you're used to using when you're taking your temperature at home. So a minimum and a maximum thermometer. Okay, it's a U-shaped thermometer, a U-shaped glass tube. In the U-shaped glass tube thermometer, there's alcohol and mercury, because when it gets hot, they will expand with the heat. So they will let us know what temperature it is. So as you can see, there's alcohol and there's mercury. If the temperature outside is hot, if the air is hot outside, the alcohol expands. So it rises from the minimum side and it pushes the mercury in front of it up the maximum side of the tube. However far the alcohol pushes the mercury up the maximum side of the tube, it'll stop at whatever degrees. So it stopped there at 25 degrees Celsius. You can see a metal pin will mark how far the mercury has reached. So that tells me the maximum temperature reached that day. If the air gets cold outside, the mercury and the alcohol contract. So they get small again. So they go back down the minimum side of the tube again, and they mark off the minimum temperature reached. So if it's hot out there, the alcohol and the mercury in the thermometer will expand. The alcohol will push the mercury up the maximum side of the tube and it'll mark off the maximum temperature reached. If it gets cold out there, as it would at night, the mercury and the alcohol contract and they move back down to the minimum side of the tube again and they will mark off the minimum temperature reached. Okay, so that's your minimum and your maximum thermometer. Right, anything else there? No. So there's just an actual picture of one. Now, if you're asked in the exam in June to calculate the mean or average temperature for the year, okay, annual temperature means the temperature for the year. So on average, what was the temperature like in Ireland for the whole year? Well, like I suppose it's not the most accurate representation, because in summer we might have 23 degrees Celsius, in winter we might have 2 degrees, okay? So like, you know, if you want an average idea of what the general temperature is like in Ireland for the year, what you do is you look at the weather months there, January to December. You see the minimum temperature is, 10 in January, 10 degrees. The maximum temperature reached was 27 degrees. Okay, so it tells you the minimum and the maximum temperatures all throughout the different months. So to calculate the mean or average temperature for the whole year, and you've probably done this in maths before, add up all of the temperatures for the whole year. So add up all the temperatures for the 12 months and divide it by 12. So as you can see, they have the calculation done below. So the total amount when you add up all the temperatures for each month, it's 216 divided by 12. So on average, the temperature for Ireland for the year is 18 degrees Celsius. So that's the mean or average annual temperature. The other one is the temperature range. So what was the difference or the range in the maximum and minimum temperatures? So to calculate the temperature range, you just minus the highest temperature from the lowest temperature. So the highest temperature reached was in August, 27 degrees. The lowest temperature was 10 degrees in January. So you minus the two of them, 17 degrees was the temperature range. And that's quite a lot when you think about it. Like from how you feel temperature-wise in January to how you feel temperature-wise in August, there's a difference in 17 degrees. So you can understand why we wear loads of woolly caps and gloves and scarves and warm coats in winter, as there's such a difference between the temperature in the summer and in the winter time. Okay, so average, mean temperature, add them all up, divide by 12. The temperature range minus the highest from the lowest. Okay, so that is the temperature. Temperature is measured using the thermometer, minimum and maximum thermometer. It's measured in degrees Celsius, and remember, the lines on the weather map are called isotherms. Isotherms, things therm for temperature, thermometer. Okay, the next thing I wanted to explain to you that you also find in a weather station is a Stevenson screen. Okay, so I'll just show you the picture of it straight away. It's a wooden box. It's painted in white so it doesn't attract the heat of the sun, because you don't want the weather equipment inside in it. It basically is a box to store the thermometers. You don't want it scorching like the thermometers or the weather equipment, because you want an accurate reading. So it's a white box painted white so it doesn't attract the direct heat of the sun. Inside in it you have the minimum and maximum thermometer to measure the temperature. You have a hygrometer to measure the humidity. And I think you have a barograph to measure the pressure, the atmospheric pressure, which is the weight of the air. We'll get onto them shortly. So the Stevenson Screen is a box that basically houses the thermometer to measure the temperature, the hygrometer to measure the humidity, and the barograph to measure the atmospheric pressure. As you can see, there's slanted sides, there's vents on the sides, that allows the air in. So it allows the thermometer to measure the air temperature without the heat of the sun directly shining down on top of it, you know. So that's the Stevenson Screen. So like I said, painted white to reflect the sun, slatted sides to allow the air in but not the direct heat of the sun. It has the thermometer, the barograph to measure the pressure of the air, and the hygrometer to measure how much humidity is in the air, how much water is in the air. Okay, those words like humidity and atmospheric pressure will become easier as we move throughout this. There's another picture of a weather map with the isotherms. They're the lines on a weather map showing you what the temperature is like. Okay, the atmospheric pressure. So I've been talking about it. What actually is it? And you know what? It does affect you actually. The atmospheric pressure is the weight of the air as it presses down on the earth. At the moment, outside, it's high pressure. That means there's heavy pressure pressing down on top of us, but we're lucky. High pressure and heavy pressure means we've got a beautiful weather and beautiful day outside. However, if it was low pressure, it means the air is light, but that can bring bad weather then with it. Now, how it actually affects people is because the atmospheric pressure is the weight of air. If that's heavy or high, and that's a lot of pressure pressing down on the surface of the earth, and we're here on the surface of the earth, it can cause a lot of headaches and things in people. You know, people will say, oh my God, I have a migraine or a headache or I have sinus pains. It can actually affect some people. How do we measure atmospheric pressure? The instrument we use is called a barometer. You can also call it a barograph, but if I skip between one of the two, they're both the same thing. Okay, so we measure the weight of the air, we measure the atmospheric pressure using a barometer or a barograph. When we measure it and we know what the weight of the air is, okay, we measure it in millibars. Millibars. It's like saying your temperature is 17 degrees Celsius. The weight of the air, the atmospheric pressure, is in millibars, okay? And on a weather map, if you see lines on a weather map showing you what the atmospheric pressure is, we call them isobars. On a weather map, if it's lines showing you what the temperature is, they're isotherms. On a weather map, if the lines on the weather map show you the atmospheric pressure, that's isobars. Think barograph, barometer, isobars. It's all to do with the atmospheric pressure. Okay? So that's what a very, very basic barometer looks like. It's like someone having a pocket watch. Okay? So it's like a little clock. And you can see the needle on it, right? The needle will move in a clockwise direction if the atmospheric pressure increases. So if the atmospheric pressure, the weight of the air is high, it'll weigh down on that little clock, that little instrument, that barometer, and the needle will move in a clockwise direction. If the weight of the air decreases, the needle on the clock goes in anti-clockwise direction. If, say, you measured the atmospheric pressure this morning and it measured, we'll say, 1000 on that clock there, there is a small little silver second needle, a slighter one. You can actually set that at the 1000 and it stays there, okay? And then you can measure it later at like 5 o'clock this evening and you can compare the atmospheric pressure of the two. So that's a very, very basic looking barometer. So the needle on the clock moves in a clockwise direction if the weight of the air goes up, if there's high atmospheric pressure. This is the proper looking barometer now, okay? So this is the equipment now that the weather forecast crowd would have. So I want you to look in the middle of the picture, in the middle of the weather instrument. That's a corrugated drum. Corrugated means it's ridged, okay? So what happens is, if the weight of the air is heavy, it presses down on that drum. Think of it like a concertina, if any of you played that musical instrument. So the weight of the air presses down on the drum, and that tells us that the atmospheric pressure is high. Now, how does it record it? You can see that the drum attached to it, kind of in a roundabout way, is a silver pointer or a lever. As the drum moves, the lever moves, and that marks off at the very top of the lever, the silver lever, there's ink on it, and it marks off on the sheet of paper on the rotating drum. So you have the smaller drum in the middle, that's a corrugated drum that's ridged, and you have the bigger drum on the left-hand side, that just has a sheet of paper on it, and you can see it says Friday. So as the air presses down on the corrugated small drum in the centre, that will move up and down depending on whether the air pressure gets light or heavy. That moves the lever has ink on it, and that marks off the atmospheric pressure. It marks off the movement of the drum on the sheet of paper, okay? Anything else I need to teach you there? So there's more pictures of the barograph. They vary obviously depending on the companies that make them. Okay, so barograph measures, or the barometer or the barograph measures the weight of the air. The weight of the air is called the atmospheric pressure. Remember, the atmosphere surrounds us. What's the pressure of the air in the atmosphere? If it's heavy, it presses down on us. That's high pressure, good weather. If it's light, well then the weather is not so good. Okay, humidity. What can I tell you about humidity? Humidity, or they call it relative humidity, is the amount of water vapor in the air. Think about when we were talking about this before. When we know that if there's sunshine outside, the heat of the sun dries up the water in the rivers or in the sea, and it soaks up the water and it turns it from a liquid into a gas. Now, we don't see that water in the air as a gas. We can't see it, but you can sometimes feel it in the air. If the air is very dead and very heavy, you get that sometimes on hot days where it's just so dead, pure dead heat, and you feel like there should be a clatter of thunder, or you kind of say to yourself or someone, like, God, it should rain. If it rained, it would clear the air, because the air is holding the maximum amount of water it can possibly hold until it has to drop that water, forms a cloud and falls as rain. So humidity is the amount of water vapor in the air, okay? So how do we know how much water vapor is in the air, or how much humidity do we have? Well, you use an instrument called a hygrometer, okay? So it looks exactly like the minimum and the maximum thermometers. It looks really, really like them. So you have a dry thermometer and you have a wet thermometer. So how in the name of God are you going to know how much water is in the air if we can't see it. So what you do is, you've two thermometers side by side. The thermometer on the right hand side in the picture measures the air temperature, but it's kind of tricking it because we sit it into a little bath of water. So the thermometer is measuring the air temperature, but it's sitting in a bath of water. So it's measuring the temperature of the air as if there was 100% water vapor in the air, 100% humidity. Okay? So that will tell you what the air temperature is, as if the air outside was holding 100% water, couldn't hold anymore. Okay? The thermometer on the left hand side is a dry thermometer. So that measures the air temperature. What you do is you look at the two readings. If they're very similar, if my reading of the dry thermometer reads 30 degrees and so does my wet thermometer, that must mean that there's very high humidity in the air. That means if they're reading identical, that means that the air is 100% humidity. That's how we measure humidity in percentage. If there is a big difference in the temperature reading between the dry and the wet thermometer, say the wet thermometer is measuring 30 degrees and the dry thermometer is measuring 20 degrees, well, the big difference in between the two of them shows that there's less humidity in the air, so that we measure it in percentage. Okay, so humidity is the amount of water vapor in the air. How much water can the air hold before it has to form a cloud and fall as rain? So you have two thermometers, dry and wet. The wet thermometer measures the air temperature, but the thermometer is dipped into a little bath of water. That almost tricks the thermometer into thinking that the air has 100% water vapor, 100% humidity. The dry thermometer measures the air temperature. You check the difference between the two temperatures. If they're very similar or very close, well, then the air has very high humidity. If there's a big difference in between the two thermometers, the humidity is low. That's a good thing because, you know, we don't want rain to come and we don't want that dead heat, okay? Now, onto wind speed. What direction is the wind coming from? Is it coming from north, south, east, west? Fishermen, shippers need to know that. Maybe people playing a match. We need to know speeds of wind for, you know, is it safe to go travelling? Is it safe to send people to school? We've been closed days because of wind speeds being too high. All of that. Okay, so what you're looking at there is an anemometer. Okay, this is basically it. So that measures the speed of the wind. Okay, so the anemometer is the top part. At the bottom of the picture there you can see wind vane. Ignore the wind vane for the moment. So an anemometer measures the speed of the wind. So how fast is the wind blowing? If any of you are living up high, you'll find that the wind is always blowing in fast around your house, and because you're open, you're exposed to the wind. So how fast is the wind blowing? How do they know this in the weather forecast? So they use an instrument called an anemometer. So it has 3 cups or 4 cups, like you see in the second picture. And the faster the wind blows, the faster they spin the cups. That's attached to the meter, and it records the speed of the cup movement on the meter in kilometers per hour. So like when you hear them saying the wind speeds are going to go up to over 100 kilometers per hour, that's really fast and dangerous. Like, is it safe to be travelling and driving out in that and sending school children out in it? So wind speed is measured in kilometers per hour. It's measured using an anemometer. It's 3 cups or 4 cups that spin in the wind. The faster the wind blows, the faster they spin. It's attached to a meter, and you can read the kilometers per hour on that. The wind vane then, if I go straight to that, is an arrow. It's a free moving arrow. When the wind blows, it blows the tail of the arrow forward. So the front, the top, the head of the arrow points in the direction that the wind is blowing. Think about that logically now. So wind vane tells you the direction that the wind is blowing from. The wind blows the tail of the arrow forward. It blows it forward. But the head of the arrow is left pointing in the direction from the wind is blowing. So is it blowing from the north, south, east or west? Okay, sometimes different homes have them on the outside of their walls or whatever. You might see them. They're easy to mount them and easy to read them. Finally then, if you want to know how strong the wind is, how strong was the wind during Storm Barra, for example, It's measured using the Beaufort scale. It's kind of like the Richter scale for the earthquakes. The Beaufort scale is a scale of 1 to 12 or 0 to 12. And the higher up in the scale you go, the stronger the wind. So you can go from calm and gentle breeze at 0 or 3 in the Beaufort scale up to 9 and 12, which would be a strong gale or a hurricane. Okay, now you mightn't have heard of it that much because we tend to talk about the speed of wind and what direction it's blowing from. But the Beaufort scale, imagine, was named after an Irishman actually. So interesting piece of information there for you. Right, we're nearly done. Precipitation, as I'm sure you remember from primary school, is rain, hail, sleet or snow. So how much rain fell yesterday? They'd say in millimetres. Now millimetres means nothing to you because you don't know about that. If I said to you the equivalent of 2 barrels of rain fell yesterday, well, you can visualize a barrel of water, so you know what that means. Okay, but if I said 200 millimeters fell yesterday, you might be a bit unsure what I mean by that. So precipitation is rain, hail, sleet or snow. How do we know how much rain, hail, sleet or snow fell? You measure it using a rain gauge. Okay, so a rain gauge is the weather instrument that's used to measure the amount of rain that has fallen. However much rain has fallen in that rain gauge, we measure it in millimeters. And on a weather map, if they have lines on the weather map that show you how much rain is going to fall, they're called isotherms. Isotherms. Remember, the isotherms showed you the lines of the temperature. The isobars showed you the lines of the atmospheric pressure. And the isotherms show you the lines on the map showing you what rain is going to fall. So think it's yet to start raining. Okay, so what does the rain gauge look like? It's basically got a funnel and a glass cylinder and an outer cylinder. So what you do is you sit the glass cylinder to protect it into an outer cylinder and you partially bury it in the ground outside. And you bury it in a place that's open. You don't want a wall or anything sheltering it because you want to measure accurately how much rain has fallen. So you partially bury the glass cylinder inside in the outer cylinder into the ground, outside in the open. You sit a funnel into the glass cylinder and that directs the rainfall in. I'm sure you've used the funnels inside in science labs before. On the glass cylinder, it's marked off in millimetres. Every day the meteorologist or anyone working in a weather station will take out that glass cylinder and they will check how much rain has fallen in millimetres. Okay, there's a very, very simple one there. Anything else? No, on to the final one. So how do we measure sunshine? So they might say like we had in summer we had like 5 hours of sunshine a day, whereas in January we only had 3 hours of sunshine. How do they know how many hours of sunshine we have? So what they use is a Campbell Stokes sunshine recorder. I know it's an unusual name, so you're looking at it there. So a Campbell Stokes sunshine recorder is a glass ball, a glass sphere, okay? And because it's a glass sphere or glass ball, it attracts the heat of the sun. It's going to be scorching hot like. So if it's a very sunny day outside, as the sun is moving across the sky, it attracts the heat of the sun, okay? And there's a strip of paper. Now, they're just a very plain black strip. Normally it's a white strip of paper underneath it. And as the Campbell Stokes recorder, as the glass sphere attracts the heat of the sun, the glass sphere heats up and it scorches a mark on the strip of paper, as you can see in this diagram here. And as the sun moves across the sky, the rays of the sun concentrates on a different section of the paper. So on that section of paper then it's marked off an hourly interval. So you just count up the scorch marks, basically. That's all that you do. So keep it simple for yourself. The Campbell Stokes sunshine recorder is a glass ball, a glass sphere. It attracts the heat of the sun. There's a strip of paper underneath it. As the sun shines on the Campbell Stokes recorder, it scorches off burn marks on the piece of paper. You count them up in hours. That tells you how many hours of sunshine shone yesterday. And then on a weather map, if you have lines on a weather map showing you places of sunshine, they're called isohells. So think of sun doesn't shine in hell. So the isoyets were the lines showing you precipitation. The isotherms, lines showing you temperature. The isobars, lines showing you the atmospheric pressure. And the isohells, lines showing you the sunshine. Okay, so just to recap then, that's a barometer. Very simple one now, showing you the atmospheric pressure. The needle will move forward in a clockwise direction if the weight of the air, the atmospheric pressure, increases. It goes back in a anti-clockwise direction if the weight of the air, the atmospheric pressure, decreases. That's a rain gauge. So that measures the amount of rain that has fallen in millimeters. So you have a glass cylinder, sits into an outer cylinder, the funnel directs the rainfall in. That's a minimum and a maximum thermometer. So you have a minimum and a maximum side. You have alcohol, and it measures the temperature obviously in degrees Celsius. You have alcohol and mercury in the thermometer. It's a U-shaped glass tube. If it's warm in the air outside, it heats the mercury in the alcohol. The alcohol expands and it pushes the mercury up the maximum side of the tube. That marks off the maximum temperature reached. If the air temperature gets cooler, the mercury and the alcohol contract and they move back down the minimum side of the tube, and that marks off the minimum thermometer or minimum temperature reached in the day. That's a barograph or a barometer. That measures the weight of the air, the atmospheric pressure. So you have a corrugated small drum with ridges in it. As the weight of the air gets heavy, it presses down on the drum. That's attached to a lever. The lever has ink in it, and it marks off on a rotating drum of paper the movement of the weight of the drum. That'll tell you if it's very high atmospheric pressure or very low. So atmospheric pressure, the unit of measurement is millibars. That's an anemometer. That measures the speed of the wind. So the faster the wind blows, the faster the cups rotate in the wind. And that's measured in kilometers per hour. That is a hygrometer. That measures the humidity in the air, which is the amount of water vapor. So you have a dry thermometer and a wet thermometer. The wet thermometer measures the air temperature, but it's fully sitting in a glass or in a bath of water, as if the air was holding 100% water vapor. So humidity would be 100%. The dry thermometer measures the air temperature outside. You minus the you don't. You look at the two temperatures in each of the two thermometers. If they're very similar or very close in readings, that means that the humidity is very high outside. If there's a big difference between the two of them, the temperature is, or the humidity is low. That's a wind vane. The wind blows the tail of the arrow forward, and the arrow points in the direction, the head of the arrow points in the direction that the wind is blowing from. That's a Stevenson screen. It houses weather instruments like the thermometer, the hygrometer, and the barometer. That's the Campbell Stokes sunshine recorder. It's a glass sphere, tracks the heat of the sun, scorches the burn marks of the heat on a sheet of paper. Hours. It measures the sunshine in hours. Okay? Hope that helps.